You might not realize it, but simple aluminum extrusions like these are the literal and metaphorical backbone of do-it-yourself engineering projects. Used in everything from 3D printers to CNC machines, desks, jigs, and much, much more, they provide a lightweight, rigid, and versatile solution to all types of engineering challenges. And yet, for many of the things that we use them for as makers, we don't need all of their strength or their weight. So recently, when I started researching a project that required some of the less usual types of 2020 profiles than the ones I keep on hand, I had the same thought that regularly crosses every 3D printer owner's mind. I bet I could print that, and it would be better than the original. So in this video, we're gonna see if I'm right. I mean, with today's 3D printers and the wide range of super strong composite materials, can you actually 3D print strong, functional profiles suitable for your own DIY projects? Or will I just waste about a week of my time and 6 different kinds of very expensive filament on something that I probably should have just bought off the shelf? I actually learned a lot throughout this process, and I'm really excited to share it with you. So let's get after it. So what do we need to achieve to make this little experiment a success? Well, first of all, I think it kind of goes without saying, but if we're going to use these extrusions in an actual project, and we are, if you stick around to the end of the video. No. Yes, I'm an idiot.
The moment of truth, I'm really nervous about this part.
We need them to be straight and at least moderately dimensionally accurate. Additionally, they need to be strong and rigid. I mean, the whole purpose of aluminum extrusions in projects is to provide a strong and rigid frame. And finally, for most of the applications that you and I would use them for, that is in and around 3D printers, they need to have at least moderate heat resistance, something like up to 60 degrees Celsius or nearby it. So let's see. Dimensional accuracy, rigidity, and heat resistance. We're gonna need to break out the carbon fiber filaments. So first off, I wanted to try printing these out of this roll of PETG-CF from atomic filament for one simple reason. PETG, unlike the other exotic carbon filaments I have on hand, can be printed on an open printer. Yes, I have plenty of enclosed printers all the way up to 350 millimeters cubed, but if I want to be able to print big extrusions, then we're going to need to rely on an open printer like the Somol SV08 Max, or better yet, the IdeaMaker IR3V2 belt printer. The latter has a number of benefits. Obviously, it will allow us to print infinitely long, but what's more, because it prints at 45 degrees, it will also allow us to print almost the entire extrusion with no supports. We just need to support the very, very beginning, and then the rest of the extrusion will actually print as is, saving us time, material, and the risk of failure if supports detach. So let's go ahead and download the extrusion type that we need, scale it to the appropriate length, and get to printing. Okay, so the extrusion printed, but obviously, as you can see, we've got some major issues. There are no profiles for this printer for any carbon fiber filaments, and I'm really impatient, so I'm kind of tweaking and testing things as I go along. Now, even after sanding this extrusion down, and yes, don't worry, I wore a respirator, and then I used the HEPA-filtered compressed air canister from Hoto to suck up the dust. Side note, actually, I'm considering doing an entire video about some of the more premium maker tools that are coming on the market right now, so do let me know in the comments below if that's a video that you'd like to see, and make sure to subscribe, obviously. Anyways, back to the issues with this extrusion. First, it is almost impossible to get the TPU strips that I printed to actually slide in. There are just too many little globs, and there's just too much friction with the carbon fiber. Second, this thing is anything but rigid. I was really hoping that the carbon fiber would make the PETG, which is generally pretty bendy, much more rigid, but as you can see, this isn't gonna work. To the rep rack. But while I'm picking up which filament to try next, now is a good time to let you know about this video's sponsor, PCBWay. Sure, it's fun to try and make your own versions of stuff that you normally need to buy, but eventually, every maker will run into limitations on some project, whether that's 3D printing something bigger than your current 3D printer can handle, having custom PCBs made, or even exotic fabrication techniques like CNC milling titanium or 3D printing tool steel. No matter what it is, PCBWay can do all of it. And all you need to do is upload your parts on their website, choose how you want them made, and then sit back. They'll do everything else from checking your design to quality control, and the parts just show up at your doorstep ready to use in your next project. So to check them out and get $5 off your first order, visit the link in the description or scan the QR code appearing on screen now. All right, let's get back to the video. Up next, I want to try this ASA glass fiber that Soraya Tech recently sent over. Now technically, you should print this and any ABS or ASA on an enclosed printer with a 110-degree heated bed, but we don't have either of those things on this printer, so I'm kind of hoping that the combination of carbon fiber for stability plus very high temperatures in the print farm, plus thoroughly cleaning the bed and then applying channel sponsor Magigoo's new Super Grip product will overcompensate. Here, once again, we don't have any profiles for the IR3V2, so we're just gonna have to guesstimate, tweak the parameters as we go along. So let's go give it a try. Okay, so that didn't work for a couple of reasons, but it was quite informative, as failure honestly always is. First of all, as you can see, I forgot to adjust the cooling settings when I copied my PETG profile, so we did get some warping at the beginning before I managed to turn the fan down. The rest of it honestly worked pretty great until the point that the printer had a thermal issue. Unfortunately, when I was printing PETG, I'd actually applied glue stick to prevent it from sticking too much to the bed and further destroying it like I did the last time I printed PETG. But yeah, that strategy really backfired because it resulted in a blob monster, and while I thought that I had cleaned up the entire hot end, apparently I didn't. Anyways, the end of this extrusion did warp up, and I'm still worried about the friction of the carbon fiber when sliding in the TPU pieces. So just for a sanity check, I want to switch to plain old ASA and see what happens. Why ASA? Well, in my experience, the version of ASA that I'm using, Polymaker's ASA, warps a lot less than other brands and certainly a lot less than normal ABS, and it can even sometimes be printed on an open printer. Also, it has a pretty high heat resistance at around 93 degrees C, which is way more than we need for the project we're gonna do at the end of the video. Now, we're gonna give it a quick try and see how it works, and then if it does, we can go back to ASA-CF, or I do have a few other ideas that we can try. All right, so I did continue having a bunch of thermal errors on the hot end, hence these failed prints you can see here, and I ended up spending like an hour or more taking apart the entire hot end, drilling out some strip screws that were preventing me from getting a nice seal with the heat sink, and then cleaning out all the gunk, etc. But in the end, it probably was just a loose thermistor connection. That's honestly a great lesson both for all of you and for myself. Don't assume you know what the issue is. It's always still worth checking out the obvious, silly possible causes before you go down the fix-it rabbit hole. But hey, whatever, at least the printer is fixed. And I did manage to get a full extrusion printed, but we are still not completely out of the woods here. See, although the Magigoo Super Grip is doing a pretty admirable job holding the print down to the print bed, it is still warping ever so slightly in the beginning, and I think I know why. See, this is a belt printer, and although the belt is very taut against the rollers, obviously there's enough play in there for it to roll without excessive friction. So what I think is happening is at the beginning, before it has other print to hold it down, the extrusion wants to warp really badly, but it can't detach because of the Magigoo. It can, however, pull up the excess slack from the belt, giving us just a tiny little bit of warping at the beginning. And actually, I think that a lot of the print quality issues that I've been having both before and on this are actually caused by that little bit of belt movement. If you actually look closely at this while it's printing, the nozzle is scraping against the part, which normally would not be that big of an issue, but since it already wants to pull up, it's lifting the part ever so slightly. I actually thought that this was a pressure advance issue, but the weird thing is it's only happening on the 2 bottom corners and only after a certain height. And so I think it actually has to do with the belt not being completely fixed in place and just slightly moving. Yes, we could now go back and try the ASA glass fiber now that we've fixed the printer, and we can see if the addition of glass fibers is enough to ameliorate that warping a little bit, but that still might not fix the issue of the bed lifting up ever so slightly, and with the friction of carbon fiber, it might actually be worse. So in the meantime, I do want to try some PPA-CF or nylon carbon fiber, which I've already got decent profiles for, but I actually want to try to print it out on a normal printer where the bed doesn't lift up so easily. The thing is, for the project that I'm planning, which again, we're going to get to, I need extrusions as long as 530 millimeters. If only I had an enclosed printer that could print something that big. Oh, snap! Maker. I do, kinda. For some reason, Snapmaker's own software doesn't want to let me print an object this big on the Snapmaker Artisan, but fortunately, you can actually use it with Orca Slicer, and that means that you have way more available profiles than the IdeaMaker software we were using before with the belt printer, and it means we have a lot more granular control. In fact, I might just try something a little crazy later to solve our little TPU insertion issue, but first, let's see if this thing can actually handle this carbon fiber nylon, which I got from YX Polymer. Hot end wise, it can go to 300C, but the heated bed can only do 110 in the very middle. The rest of it reaches a max of 80. Fortunately, Magigoo also has a product specifically designed for nylon, and they've told me that you could even print nylon in an open printer with it, those mad lads. So why don't we give it a try? All right, well, that didn't work, but not for the reasons that I thought. Actually, the print stayed down really rock solid. The problem was actually with the supports. For this project, I needed an extrusion with 3 open sides, and since printing this thing standing up would be extremely weak and probably not straight at all, that means using supports for inside the slots. But it seems like the default profiles in Orca Slicer for this printer use 0 clearance because they intend for you to use a different support material like a breakaway support or even a dissolvable support, which I've done with this printer in the past. So I didn't check that, and it seems like we got a collision, which caused a very expensive spaghetti monster. This is really promising though. The part that did printed absolutely beautifully. I think if I just figure out the support settings, we can get a completed profile, but I am still worried. I'm worried, first of all, that the supports will make the edges jagged, which will make it even harder to slide in those TPU strips that I printed out. Second, I'm worried about more expensive failures if those tiny supports fall over or collide with the print head. If only there was like a way that I could insert the TPU strip midway as the extrusion is printing. Double snap, Maker. I just realized that the Snapmaker Artisan does have dual extrusion, which is 1 printer and 2 nozzles. So in theory, I could orient the part in such a way that I'd only need supports on one side, which wouldn't have to be perfect because the TPU strip would already be in the channel where I actually need it. And plus, the TPU itself could actually support the overhangs of that top channel. It's risky, but if this works, I'm a genius. It didn't work. Specifically because I'm not a genius, I'm an idiot. Well, actually, it was working, but I wanted to get some really nice B-roll for all of you guys, and I kinda left a tripod leg in front of the bed while I was changing lenses. Oops. So I guess in a way, it was actually you guys that made the print fail, and you probably should like and subscribe if you want to make it up to me, or don't. I've honestly already forgiven you. Side note, for the folks over at Snapmaker, it would be really nice if you allowed us to home XY. Either way, this half print is really promising. I mean, look at how perfect the surfaces are and how well it's actually adhering to the build plate. And look how well the supports are sticking. I feel really good about this, and also check out just how rigid it is, even though it's only like a third of profile. This time, there's no way this doesn't work. Yeah, that still didn't work. For all its great traits and qualities, the Snapmaker Artisan has an extruder that is basically wholly incompatible with flexible filaments. I tried multiple times with multiple different setups to try and reduce the amount of friction on the filament, and it just was not happening. Plus, the high friction of the carbon fiber filament in the long Bowden tube seems to have caused some under extrusion throughout the entire print. This video is starting to get pretty long, and I'm really trying to keep my videos under 24 minutes these days, plus we still have an actual project to build. So let's just skip to the nuclear option. Tech recently sent me over some of their PPA-CF material, which is supposed to offer metal-like strength. Now, initially, I actually loaded up basically the strongest filament money can buy, at least for consumers, and that's Polymaker's pps-cf. But then I did the calculation and realized that it would actually cost more to print these with that material than it would cost to buy them. So why don't we try out the much cheaper PPA-CF from Tech? Check it out. I printed these extrusions on the Creality K2 Plus at around 310 degrees Celsius directly from Sunlu's E2 filament dryer running at 110 degrees C. I also generously applied Magigoo's PA bed adhesion product, and I honestly expected some failures and tuning, but to my surprise, they printed absolutely perfectly the first time without a hitch. I also had been worried about supports and removability on such a strong material, but the profiles on the K2 honestly were actually really good, and support removal was, look at this, no problem. The only annoying thing was that there's actually no way to select PPA-CF on the printer, and it won't let you print unless the material matches the G code. So I think I ended up just telling it that it was pps-cf, since honestly, they're close enough. Also, by the way, I think all my fears about the friction of adding in the sealing strips were probably unfounded, because once I got perfectly dialed in profiles, look at this, they actually slide in like shockingly well. And they fit beautifully. The only issue is build volume. Our project calls for 2 of these 470 millimeter extrusions, which we have, but we also need 2 530 millimeter ones. And the only non-belt printer that I have that can print that big is gonna be the Sobel SV08 Max. And unfortunately, as I always seem to do with pre-production printers, I broke it. I'm not sure how, but it seems like I fried the heater bed. Also, it's not enclosed yet. They haven't released the enclosure yet. So why don't we head back to the Snapmaker Artisan with our tail in between our legs and see if we can get it to print this material, maybe by reducing the friction as much as possible on the filament path so that we don't get any of that under extrusion. Let's see how it goes. But remember, we didn't just print these profiles to prove that we could do it. We printed them to use them in an actual project. So will they actually work? Are they accurate enough and strong enough to actually serve their intended purpose? Or will the walls of the V-slots crack the second I try to affix some T-nuts to them? I guess there's really only one way to find out. Cue the assembly montage. No! No!
All right, we have it assembled. Now, the moment of truth. I'm really nervous about this part. It actually works. No way. I can't believe it works.
So yeah, for non-structural parts like this clicky-clacky door mod, it turns out that you can, in fact, just as our merch suggests, just print it. And actually, I will admit that I originally pilot tested this idea about 6 months ago when I 3D printed a cross-brace extrusion to help support the weight of the multi-material unit on top of the printer. I just didn't know if it would work with something that had to move and take different forces. With that said, there are still definitely some caveats and future improvements for this idea. First of all, during the assembly, the extrusions did break in a bunch of predictable places, though interestingly, only the ones that were printed on the Snapmaker, which I attribute to the relatively low 300°C max nozzle temperature, combined with the lack of a heated chamber. The ones printed on the K2 Plus at 320°C and a high internal chamber temperature were actually surprisingly robust. To get this project done, as you probably noticed, I ended up just welding the plastic together at all the different joints, which wasn't glamorous, but got it done. But honestly, looking at some of the samples that I printed in plain old ASA, I think that the slots on those actually might be stronger. And that makes sense since additives do add rigidity, but they compromise layer adhesion. I think that in order for this to work, you really need to give the material the ideal conditions for layer adhesion. So I'd be interested to retry printing these in an enclosed printer in ASA or even PPA-CF once I enclose either the belt printer or the Sovol SV08 Max. Or maybe one of you wants to experiment with printing these on Polymaker's new HT PLA, which despite being printable on an open printer, should be really rigid and withstand, obviously, the temperatures we need for most purposes. Additionally, if you are planning on recreating this project at home, just note that I was way off about the TPU inserts. It turns out that after all my worrying about the TPU strips, it was a total non-issue because the ones that I'd searched for and printed were not at all what the project calls for. I took those out and I designed two of my own designs, which are currently printing in the other room. One inserts in between the acrylic and the extrusion, holding it in place and sealing it the way the designer of this mod originally intended, and the other is basically just a thicker extrusion cover to provide a seal between the door and the printer itself, which I personally think looks a lot cooler than your basic foam tape. It's projects like these, by the way, that make me really grateful that Polymaker is a channel sponsor, because there are very few filament companies out there that actually match their different colors across different types of filament. And look, I know that 3D printed extrusions are not going to replace aluminum ones anytime soon, and that aluminum extrusions are cheap, readily available, and more recyclable than plastic. But I still think it is a fun and promising way to either reduce the cost or the weight of some aspects of your builds, or make it so that you can get a project done without having to wait for extrusions on order. But hey, I'd love to know what you think in the comments. Would you do this for part of your next build, or was this a totally silly project to you? I'd also love to know if you like this type of video where I have a crazy idea and I experiment with it to see if and how it's even possible with 3D printing. I really enjoyed making this video, so if you'd like to see more like this, just let me know down below. Anyways, that's all for this week, but I'll see all of you on the next layer.